Hey space friend, would you believe me if I told you that the ship's AI locked me in the cryo-chamber again for 9 months? I'm definitely going to have to do something about this. Today we're going to use an OLED, buzzer, LEDs, and push button to install an empathy module on the AI and reset its shenanigans. For this project we need a green and red LED, two 220 ohm resistors, a push button, an OLED display, a buzzer module, a breadboard, and 17 jumper wires, 9 of them male to female. The libraries we're including here let the Arduino talk to the OLED screen. I'll include a link at the end of this video if you want more information on how OLED displays work. SPI handles the communication with the display, Adafruit GFX gives drawing and text functions, and Adafruit SSD 1331 is a specific driver for this OLED. Adafruit SSD 1331 display creates the display object. The Arduino needs to know which pin selects the screen, which is CS or chip select, which pin controls data and commands, which is DC, and which pin is for the reset, which is reset. Last button state and current button state track the state of the button over time. Since we're using input pull-up, high is going to mean that the button is not pressed, and low means that the button is pressed. So these variables store what was the button doing before and what's the button doing now. That lets the code detect the button is currently being pressed instead of the button is currently being held down. Without this, holding the button down for half a second might make it skip through multiple stages instantly. Last debounce time stores the last time that the button changed state. Debounce delay is the debounce duration in milliseconds. Mechanical buttons don't make one perfectly clean connection when they're pressed. They bounce around physically a little bit. So one press might electrically look like on off real quick. Debouncing filters that noise out, so when we press the button it says ignore any debounce for 50 milliseconds. Reset stage is the variable that will let us progress through the steps. Each press is going to increase this variable by 1. Then the show stage function checks the number and then displays the matching screen. Final stage defines the maximum stage number. Using a variable instead of just hard coding 6 everywhere is going to make it easier to make changes later if we wanted to. These const int variables are going to say which component goes to which Arduino pin. Then pin mode button pin input pull-up sets the button pin as an input and uses the Arduino's internal pull-up resistor. The displays in the setup start the screen, fill it with black to clear it, and set the text size. Random seed sets up the Arduino's random number generator. By default, Arduino's random function isn't truly random. If you don't set a seed, it generates the exact same sequence every time that the board resets. So without this, the AI glitches that we're including would be in the exact same order every time that we turn it on. A seed is the starting value for a pseudo-random sequence. The reason we use analog read A0 is because if nothing is connected to analog pin A0, then the pin just floats. That means it picks up tiny random electrical noises from things like nearby electronics, static, or electromagnetic interference. So this way it returns a semi-random number and then that randomness is used as the seed. Boot sequence and show stage are called next, which are just functions that we'll get to further into the project. For the main loop, which Arduino is going to repeat forever, the loop only has one job: check whether the button is pressed or not. The read button function prevents the code from advancing constantly while the button is held down. Was pressed remembers whether the button was already pressed during the previous loop. So if is pressed and isn't was pressed means only trigger the button when the button first changes from unpressed to pressed. Advanced reset is a function that we'll create next, and the delay is a simple debounce so that one press doesn't accidentally count as multiple presses. The advanced reset function does the main logic of this project. When the button is pressed, increase the stage number, play a confirmation beep, show a special glitch screen on certain stages, and then show the current stage screen and then pause so it's readable. We do this if reset stage is less than final stage, otherwise we call the show final safe mode function. The boot sequence function calls the set LEDs function that we'll write later to turn on the red LED only. Then we set the screen to black to clear it, set the cursor to the first column of the first row, and display various text and colors to the OLED display. The show stage function updates the screen based on the current reset stage. The switch statement is basically a cleaner version of a bunch of if statements. Each case is turning on a certain LED and then printing text depending on the stage that we're on. So for example, case 3, if reset stage is 3, show the stage 3 screen and turn on the green LED. Each case ends with break to prevent the code from accidentally continuing into the next case. The Show AI Thought Glitch function turns the red LED on, prints text to the OLED display, and creates a buzzer tone while it's talking. The Show Carbon Decision Maker Glitch function is similar. It's just a different glitch to pop up in between stages that we're clicking through. They'll show up on the stages that we set them to in the Advanced Reset function. The Show Final Safe Mode function turns just the green LED on, displays various text to the OLED display, and then calls the success sound that we'll define later. The Set LEDs function is a helper function that just makes the LED code easier to read. So instead of writing digital write red pin high, digital write green pin high, you can just do set LEDs true or false, with red being the first argument and green being the second one. For the beep confirm function, tone plays a frequency on the buzzer. A higher number is a higher pitch and a lower number is a lower pitch. No tone stops the sound. This is the initial sound we hear when Advanced Reset runs. The alarm sound function is initializing I to 0, and while I is less than 3, increase I incrementally by 1. It's just play the tone and turn it off. This is called in the boot sequence in between messages. The warning sound function is playing a different tone, and it's called in case 4 when the AI is resisting the update. The success sound function plays a different tone and is called when the Show Final Safe Mode function is called in case 6. Now let's test out the reset and see if it works. Perfect. The AI has officially agreed to stop imprisoning me for my own safety. Legally binding? No. But emotionally reassuring? Also no. Ugh, somebody is playing music so loud in the vacuum. How? Are you kidding me? Go away. Okay, immersion break. There are construction workers outside my window right now, absolutely blasting music. Non-immersion break. The aliens are blasting music.